Let's see the program for PIC microcontroller for PWM mode and its simulation. Programming is using MPLAB software and its simulation using Proteus software. Then click on File, go to New Project, select categories as Microchip Embedded, select Project as Standalone Project, click on Next, select the family as Advanced 8-bit PIC Microcontroller. I am selecting here PIC Microcontroller as PIC 18F4520. Click on Next. Then select hardware tool as pick kit 2, then compiler as XC8, click on next, give your name as PWM1, then click on finish. Here you will get the files for your project. Right click on header file, select new C header file, then give your name as PWM1, extension is .h for header file, click on finish. Your software will create its own header file. We don't want, just cut it down, then just go to window option, click on pick memory view, select configuration bits. Here you will get the configuration bits for your project. Then just we don't want the watchdog timer, so just off this and click on generate to source code to output. Don't fail to disable the watchdog timer. Here you will get generated source code for output. Select this source code and copy this source code to our header file window. This here, just add here the crystal value as hash define XTAL as 8 megahertz is required for PIC 18A4520. Just right click to source file, see new, see main file, then give your name as PWM1, extension is .c. Finish this. I have written the source code. Now I have written the source code for the PWM. Then just am including here my header file as in double inverted comma as PWM1 dot h. Okay. Now I have written here the source code for the PWM. Just I have written this source code for frequency of 10 kilohertz for 50% of duty cycle. So time is 100 microseconds. T on and T off of every T on and T off is 50 microseconds. So F oscillator frequency we are selecting here 4 megahertz and oscillate. So T oscillator is 1 upon F oscillator. So I am calculated here as 0.25 microseconds seconds. Okay, then this is the formula I have taken from the PIC microcontroller PDF or data sheet. PWM period equal to PR2 plus 1 into a 4 into T oscillator free scale value. Then I have calculated PR2 value. I am selecting here as 99. Just build this program. Build successful. Just see this program is working with Proteus or not. Just simulate this with Proteus. This is the diagram for the I am selecting here digital oscilloscope connecting to RC1. Just putting here the program file. Here I am selecting clock frequency 4 megahertz. Then OK. Just run this program. Then Here we are selecting the channel B. So just here you will get the T on and T off as 50% or 50 half. So T on is equals to T off. So 50% duty cycle is getting here. So our program simulation is correct or program code is correct.